All right, we've reached the last part of this set of notes talking about double replacement reactions. First of all, how do we recognize a double replacement reaction? It's going to be two compounds. It's a compound reacting with another compound. That's pretty much it. That's the only one that is a compound reacting with another compound. So that's how you can recognize that this is a double replacement reaction. Remember that when you're swapping ions, the cations always pair up with the anions. Or you could think of it as the cations switching places with each other. Okay, so this is a cation, this is a cation, this is an anion, this is an anion. The cations are going to trade places so that they are pairing up with anions. The other thing we have to remember is to always do the crisscross and keep your charge consistent. So in this case, we've kind of got something a little different. Fe, that's a metal that we don't typically know the charge of, so we got to think about it a little bit. Hydroxide has a -1 charge, so 3 times -1 gives us a -3 charge, which means Fe has to be +3. Okay, so Fe is still going to be +3 on the other side. All right, hydrogen has a +1 charge because it's in group 1. And then sulfide, it makes sense that it would have a -2 charge because it's paired up with 2 positive 1s. Okay, and it's also in group 6A, which is usually a -2 charge anyway. All right, going to the other side, we're going to make some compounds. We end up with Fe pairing up with sulfide, so these two are going to get together. Fe and sulfide are going to get together. Fe and S. Now Fe has a +3 charge, S has a -2 charge. They're going to trade places. The 2 will go here, the 3 is going to go here, and then we erase those charges. You don't want those in your final formula. All right, now hydrogen is going to get with hydroxide. So we have H and OH. So I have a +1 charge, and hydroxide overall has a -1 charge. So I don't really need to write those charges because they're already neutral. And we erase them at the end anyway. Now let's balance. All right, I have 2 Fe. Let's try putting a 2 here and see what that does. 2 times 3 is 6 hydroxide. So put a 6 right here for the hydroxides. All right. Now let's look at our sulfurs. I have 3 sulfurs on the right and only 1 on the left. So I'm going to put a 3 right here. Hydrogen's the weird one in this case because it's in 2 places on both sides. So let's add them up. I have 2 times 3 to give me 6 hydrogens. And over here I have 3 times 2 to give me 6 hydrogens. 6 plus 6 is 12. Let's look at the other side. 6, and there are 2 hydrogens in this. 6 times 2 is 12. All right, we're balanced. You could put a 1 here if you'd like. Okay, let's look at the last one. Try it out if you feel like you've got it, and then you can check your answer. I've got silver nitrate reacting with potassium chloride. Silver and potassium are going to switch places. Nitrate and chlorine are going to switch places. All right, silver has a +1 charge, we know that. Nitrate has a -1 charge. Potassium has a +1 charge, and chlorine has a -1 charge. We could find those we could find silver on the periodic table. It's right here. Memorize that charge if you don't already know it. And then chloride is right here. It has a -1 charge in that group 1 or group 17, 7A. Polyatomic ions, nitrate has a -1 charge. It's right here. So that's where I'm getting this information: periodic table and the polyatomic ion list. And of course, potassium is in group 1, so it's +1. Now let's go ahead and make our compounds on the other side. So I'm going to start with silver. and chloride. Remember, silver's +1, chloride's -1. That's already neutral. Don't worry about writing those charges. We don't even need to do the crisscross. And then I have K, which is +1, and NO3, which is -1. Those are already neutral. They balance each other out. So that's it. We have AgCl and KNO3. I see that I have one Ag, one Ag. I have one NO3, I have one NO3. If I think of that as a unit, I could group it like that if I wanted to. I see one K and one Cl. Everything's already balanced. All right, try your hand at the practice. Let us know if you have any questions.